So I want to start off with two things. First of all, there's a Discord channel for this talk, and I'll be checking messages as often as I can remember to. If you have anything to say, that's an option. The second thing is Emily Joleo gave an excellent talk yesterday on how to find the right scenarios to use mock. And if you weren't there, I strongly recommend you to check it out. And this talk is about how to find the wrong scenarios to use mock. So you're very well covered. My name's Jenny, and I work at Piccolage. We build apps and try to make people to use them. 2 years ago, we were the main sponsor at RubyConf Taiwan. As a sponsor, we got a nice booth and a chance to display some swags. I took the opportunity to print out my first ever Ruby joke sticker. Thank you. Great crowd. Let's talk about Douglas Adams. Some of you might have heard of him because he wrote this little series called Hitchhiker's Guide to the Galaxy. Yay. In this book, we learned that each major civilization tends to pass through three distinct phases, those of survival, inquiry, and sophistication. And we can easily memorize them with three words: the how, why, and where. Specifically, we can expand the questions to how can we eat? Why do we eat? And where should we have lunch? Let's talk about testing. Likewise, my relationship with testing has gone through three distinct phases as well. The survival phase is how to use testables. The philosophical or the inquiry phase would be, why do I test? And sophistication really came when I arrived at this question, where should I begin to delete my old tests? Turns out, not exactly every test deserves a place in your test suite. And in this talk, I'll try to answer all of the three questions. And this is how I'll do it. First, I'll give a higher-level overview of the testing universe. And then we'll dive into some specific cases of the tests that should be deleted. And I'll wrap this up by sharing tips on how to have a stronger, more sustainable relationship with your testables. So let's go. So first, let's define some terms that I'm going to use a lot in this talk, so there's no ambiguity when I say them. Testable is the catch-all term for all the fake objects that you pass in the test to substitute for the real thing. And stub, mock, and spy are the three most common categories in testables. We will not go into the difference between the three today. Just know that in this talk, they are sort of interchangeable. Subject is the thing that you want to test. And a dependency is another module or anything outside of the subject that the subject knows. So if module A calls module B, then we will say that module A depends on module B. So now let's for a second imagine a perfect world where every piece of software is a joy to maintain and JavaScript doesn't exist. Even better, the tests in your code base actually look like this pyramid. At the bottom, we have the unit tests, which should have the highest percentage in your test suite because they are cheap and fast. And the integration tests are to make sure that when several independent components are put together, they actually work. At the top, we have the acceptance test, or end-to-end test. It is the smallest portion because it's expensive to run and maintain. So that's the ideal situation. In reality, you probably won't get that. There will be some tests that you kind of see their intention, despite what they have become. And then there will be tests that are just as confused as you are. So we have the integration tests wannabe and the helicopter unit tests, both of which I will explain in a minute. At the top, we have screen tests. It's actually very cheap to maintain because there's no test. You only need a screaming manager to know when things have gone wrong. So let's first look at integration test wannabes. Let's talk about lunch. So this is a restaurant service. It has one method, serve French toast. And this is the implementation. First of all, we see that it gets a chef and waiter from their respective classes. And chef makes French toast, which waiter will serve. In the middle, there's this condition that says if the waiter is angry, they will eat the French toast and abort the operation by raising the error. So we open the test file and see this test. We immediately know that it's an integration test because there's no variable assignment in these two lines, so they must be changing some states of the system. And also, we secretly know that they are all active record objects, and that's fine. What's not fine is this line. It's a test double for a method in floor. We didn't see that in our production code. So now to find out what this test double is for, we have no other choice but to look at each line, look into each line. So first, we look at chef. It sends a query to the database, not what we're looking for. The second line is getting a waiter. This is more interesting. It not only makes a database query, but also makes a database command. And at this point, you might be thinking of one thing. It's the callback. We see that the update action will trigger this piece of code in the before save hook. And sure enough, we found the floor. So the logic of this piece of code reads, unless the floor is scrubbed, the waiter has to scrub it and be angry. And if we remember, when the waiter is angry, they will eat the food and raise an exception. But because we are testing the happiest of paths, we don't want to trigger this. So to be able to do so, we need to go into the floor class and see how we can make it clean. And as it turns out, the implementation of floor is all kinds of messy dependencies. We certainly don't want to create a fake file, handle the background job process, and initiate an Elasticsearch client just to test if we can serve French toast. To avoid that, the simplest solution is to use a test double. So the test will pass and the world will be perfect. So mystery solved and you feel good, except that you just witnessed the integration test wannabes. There are tests with randomly inserted test doubles because the real objects are too awkward to deal with. This is when you find yourself reaching for test doubles because it is too painful or just too awkward to set up the real thing. So what's bad about this is, first of all, if you have random test doubles like this, you will have random test failures in the future. It always comes back. So fast forward 1 month later, in the waiter class, someone decided to change the method. And so now your restaurant test fails because some distant implementation detail has changed, not because your production code is broken. And it's really sad for people who want to do refactoring. Katrina Owen, founder of Ecosystem and the co-author of 19 Bottles of OOP, has in one of her brilliant talks confessed her love for refactoring. And I agree with all my heart that refactoring is therapeutic. Just with one small precondition. Another reason that we should avoid this is that it hurts productivity. Imagine another developer comes in, that when they see that random tests doubled in their test, they are immediately faced with two options. One, they can totally ignore it and feel guilty afterwards because they didn't check it out and confirm that it's not an important business logic. Or they can go down this potential rabbit hole and confirm that it is actually really just a boring implementation detail. So Test doubles are contract between the test subject and the other object. When we decide to put a test double into a test, we are declaring that contract. And we are assuming or sometimes asserting that this contract doesn't change. Before we see how we can solve this, let's look at another category, the helicopter unit tests. Let's talk about lunch. The restaurant service is expanding. Now it adds cheese panini to the menu. The implementation, the structurally, it's basically the same. We first find available chef and waiter. Chef makes the food and waiter serves. But it's slightly more complex for the waiter. In this case, they need to get bread from the cupboard and get cheese from the fridge. And of course, if they get angry, they will have to eat the food. Before we write the test, let's look at the dependency graph. This is what we know so far. The arrows are the direction of the dependencies. And restaurant service depends on the chef and waiter class. Chef talks to the database, and so does waiter. Waiter also knows cupboard, fridge, and floor. And we also remember floor is the class that has multiple messy dependencies. I'm just going to use random emojis to represent them. So let's think about our testing strategy here. If we are writing unit tests, we know we should isolate our restaurant service from the dependencies. So we need to use testables somewhere. The more obvious targets are the database and the floor because they reach out to the outside of the system. And because so now we use testables for them. And now because they're gone, we need to let cupboard and fridge go as well. See the problem? Let's look at the code. So to achieve the effect in the graph, first we need to set up cupboard that leads to bread, and a fridge that leads to cheese. Assign them to a waiter. Add another necessary methods to the waiter. Make the waiter accessible through the real waiter class. And same goes for chef. And finally, we make the action and the test is done. We also arrived at the helicopter unit test. It is when you try to control every implementation detail in your test, like a paranoid parent. First of all, it would be like you're building your own fake empire, where it's so detached from reality that the test will continue to pass even when other modules has since changed. So even if you push the code, the production bursts into flames, your CI will still pass. If your test cannot catch errors in your production code, you're denying their reason of existence in the world. Another situation for helicopter unit tests is that it produces very brittle tests. It is very likely that our tests will fall down easily. We are specifying every implementation detail. If you change anything in that method, you have to change the test code as well, or else it will fail. And the worst part is that you need to write this setup multiple times because for unit tests, we need to test every scenario. So it's not just that one test is brittle, it's a lot of tests you need to cover. So that was bleak. In the remaining part of this talk, I'm going to share some tips that I've learned that can get us through those situations. Now, this is the main point of this talk. There. If you forget everything else in the talk, which I wish you don't, I hope you at least remember this. If you find it's really hard to write a test without making it awkward, it probably means that you should change your production code. Tests provide surprisingly good design feedback because they are the first consumer of your API. They are that friend who will slap you in the face when you make a wrong decision. Tests are karma. If we find ourselves in a situation where there seems to be no way out, and we need to choose between writing a helicopter unit test that cannot catch errors or an integration test that has holes in it, it is because our production code makes it so. So how exactly do I avoid that, you ask? There are 3 tips that I found really useful to think about. First, use the principle of least knowledge. A very quick definition is don't talk to strangers. So let's see an example. Suppose we have this method that gets the answer to life. In order we call life, universe, and everything, and finally arrive at our answer. On the first glance, the dependency graph looks like this. But actually, life needs to know about universe and everything too, because it needs to know how to get information from these modules. They are structurally coupled. That is, if everything changes, life and universe needs to change too. And that's very exhausting and also a lot of cognitive load for developers. So the principle of least knowledge is to tell us that we should try to achieve low coupling by only talking to our immediate neighbors. And the example that we just saw uses a method chain, and that's usually a sign that we are violating the principle of least knowledge. And breaking them into lines won't make them better. Back to our Shih method. There are 2 places where this code violates the principle of least knowledge. So we shouldn't know how waiter get the cheese and bread. We just need to know that they get them. So we'll encapsulate those methods into the waiter class. Then we can remove some marking code from the test. So we don't need this anymore. Instead, we'll change them to this. Now the tests look slightly better. We are only marking the waiter and chef class instead of the whole universe. So that's the principle of least knowledge, or some people will call it the law of Demeter. Try not to violate it. The second tip I found really useful is to separate decisions and delegations. So every piece of code falls into 2 categories. Decision is about your business logic. It's a conditional statement. It's a calculation. Delegation, on the other hand, is about dependencies. It's about a relationship that this piece of code has with another piece of code somewhere else. Let's look at our Shih's method. If we look at each line and label them with either delegation or decision, we'll get this. It is a classic example of mixing delegations and decisions. What's bad about this is that if we want to test, those delegation part will be a painful setup for every branch of the decisions that you want to test. And when we want to test the delegation, the contracts, we need to pay extra attention to those decisions branches as well. So how to avoid that? If we think again about the boundaries and the responsibilities, we can actually identify 4 responsibilities that this function orchestrates. Get resources, prepare ingredients, make dish, and serve dish. So first, get resources. This part is fine by itself, so we'll leave it alone. The rest is where we get mixed delegations and decisions. So if we think about them, we can probably encapsulate those logic into waiter and a chef class. And if we do that, then the resulting code will be like this. Now this function reads, first find available chef and waiter, Waiter prepares the ingredients, chef makes a cheese panini, and waiter serves. So it becomes very straightforward. And the resulting test becomes straightforward as well. There are only one scenario because there's no decisions here. And actually, I probably won't unit test this function at all. I'll just use an integration test to cover this. So let's look at the independent components. Waiter will implement the two methods, the get ingredients from cheese panini and the serve dish. And chef will implement its make cheese panini method as well. And now that they are put into their respective classes, testing them is easy. We don't even need to use test doubles. And this unit test becomes very straightforward. And then it is also good that for the sake of not overwhelming you with a bunch of beautifully written, clear unit tests, I'll just show this one. But just know that there are a lot of unit tests you can write. So if we look back to the decision and delegation chart, we can see for the components, they focuses on logic. It fits nicely with the spirit of unit tests. And it's very cheap because we are just testing the logic. And for the components that focus on delegation, like the restaurant service that we just refactor, it fits perfectly with the integration tests because what we want to make sure of is that it can actually put the pieces together. Either way, you don't really need test doubles. So in other words, the best way to not abuse your test doubles is to not use them at all. And it ties back to our testing pyramid. When we will naturally have a lot fewer integration tests if we design our system this way. Now we have one final point to cover. Make the dependencies really obvious. Up to this point, we haven't really talked about dependencies. Specifically, how do we think about them? We know that they are important because they are the reasons why the test doubles exist. But if we step closer, we can see that there are actually two types of dependencies. Those they don't have side effects, and those they do. The ones that don't have side effects are the ones that we desire, because we don't need to guess if some remote state will be changed by calling them. On the other hand, if you have to be really careful about the rest, because they tend to reach out to the outside world and put your system into unexpected state, there are more chances that they will give you trouble. In fact, we want to make them as obvious as possible so that even if they're unstable, they're at least expected. For this, we will look back to our first example, the serve French toast. Remember, it was hard to write the integration test for it because floor has a lot of dependencies. And those dependencies are hidden inside the before save callback in the waiters class. And we also need to pay attention to the database too, because database is also something that has side effects. So how to make those dependencies obvious is the question. So if you think about it, what's obvious is that what's obvious is what we can see immediately. And what we can see immediately is the restaurant service class and this function. So what if we just move those unstable dependencies to this module? And we'll slightly rearrange so it's prettier. And even better, we can use this new module called restaurant repo to manage those unstable dependencies. And we can use dependency injection to reverse the direction of the dependencies. So that's a theory. How does that look like in code? So we first identify the ones with hidden unstable dependencies. checking the time. And put them into restaurant repo. Dependency injected. And that's it. That's our result. And we can use a plain Ruby class for our restaurant repo. It serves as a wrapper to those messy dependencies. We can separately test those dependencies if we want, and we should. But the point is, the test of our refactor serve French toast restaurant code becomes very easy. We just need to initialize an object that implements those methods and pass it in as an argument. And there is no surprising random test doubles anymore. That's it. So that brings us to our final point. If you find yourself in a situation that you're using your test doubles awkwardly, think about the code design. Specifically, think about how to write it so that you don't have to randomly stop your dependencies or fake everything away. Okay, one last thing before I let you go. I want to use this opportunity to, on stage, to share some good resources I've come across. These are definitely not comprehensive, but I try my best. These are the talks about testing, software architecture, and refactoring. Highly recommended. And there are some books, too. OK, and this is how you can find me online. Use the QR code. There's no danger. And the Discord channel is there. So if you have anything to say, you can reach out to me through that channel, too. Or just talk to me, really. OK, thank you.